everyone. I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the products we see around us every day. There's a whole new world of things waiting for us to discover here on How It's Made. We're all familiar with those perfume strips you open in magazines. But how do they put those odors into paper? Simple. The odorant is trapped inside thousands of microcapsules that, when scratched by opening the paper, release the perfume. Maybe simple, but very effective. On today's show, plastic bags, solar panels, plastic gas containers, and hockey sticks. If you buy cat food or snack foods or save leftovers or go Christmas shopping, with all their various uses, you can really get carried away with plastic bags. The plastic bags we use every day are made from granules of linear polyethylene resin that will be melted. They combine the linear polyethylene with another low-density one in this mixer. The granules are perfectly blended into a homogeneous material. Granules melt in the extruder, which heats them to a temperature varying between 180 and 240 degrees centigrade. This produces a film of polyethylene in the form of a tube. It is several hundred meters long, has a minimum thickness of 37 microns, and a circumference of 51 centimeters. The plastic tube gradually cools down. Rollers then flatten out the plastic tube. The polyethylene film is now easy to work. And now they cut the tube on two sides to obtain different rolls. This knife then cuts the film to the required width. The excess strip is salvaged in this tube. Several hundreds of meters of film are produced and rolled up. This particular roll contains the required quantity of film. When the roll is full, the film is cut. This roll moves forward and can be transported to another department. An empty roll begins to fill up automatically. A full roll weighs 158 kilos and can produce 35,000 bags. The next step, printing on the bags. This alcohol-based ink circulates continuously to retain its viscosity. Impressions are made by inking rollers. Here, another color is being applied on the bags. Once printing is over, the plastic film is rolled up again. The roll is now full and the cutting of bags can get started. This machine makes 150 bags per minute. A sealer bonds the edges of the bag together with heat. The wheel picks up the bag and puts them on two spindles that can hold 250 each. Here they're making bags with a hermetic zipper. The zipper is made from a plastic pad which inserts into a slot. The zipper is made in advance and is unrolled progressively. The zipper strip is cut and heat bonded to the bag at 180 degrees centigrade. And here's the zippered bag all finished. In this other department of the plant, they make plastic bags with handles. Printed bags circulate on these rollers. The machine that welds the sides gives the bags the desired shape. Then another machine with a punch cuts the handle holes. Bags are heat sealed and cut at 150 degrees centigrade. Here they fabricate another product, packaging bags. One end of the bag is heat sealed. This machine makes holes, which let air out of the bag when it's being filled. to allow them to be generously filled with items. At this stage, a stamper cuts the handle holes. Bags are cut to the required size, automatically sealing the other side of it. This plant makes 8 types of bags for an overall total of just over 1 million a day. Once largely ignored, non-polluting solar energy is now increasingly being captured in panels and stored in batteries to help heat buildings and generate electricity. Welcome to the future, under the sun. The sun is able to produce electricity. Panels covered with photovoltaic cells convert sunlight into electricity. This blue plate is a module made of crystalline silicon. The grooves are the conductors, and the silicon crystals glisten at its surface. To make a solar panel, several modules have to be connected together. Then they apply a soldering flux on each module. The soldering wire is heated with an iron. The modules are placed on a special support. Once the soldering is done, the modules are cleaned by ultrasound in water at 60 degrees centigrade. When dried, the perfectly clean modules are ready to be assembled. Now they can proceed with soldering the modules by groups. First, a flux is applied which improves the quality of the soldering. With great dexterity, they assemble 4 groups composed of 9 modules each. In this way, 36 modules are soldered and connected in series. Modules are assembled end to end. They have to be handled with great care. Using a voltmeter, the voltage of each module is verified. At this stage, it's easy to remake a solder connection if there's a problem. If the voltage is adequate, they use suction grips to make handling of the 9 rows of modules easier and to keep them clean. The modules are placed into position. Then this metallic strip is inserted, which is a conductor that will link the 4 groups of 9 modules. Solder connections are made to link the modules to the metallic strip. Then they put on this transparent sheet of layered glass. It serves as a rigid, transparent form which will support the modules. Superposing of parts forms a laminate which increases the rigidity and solidity of the panel. Finally, a sealing film is applied to protect the module. To laminate and stiffen the solar panel, it's placed in a heated oven from which air has been vacuumed out. The panel will cook at 80 degrees centigrade for 15 minutes. The oven hermetically reseals to proceed with the vacuuming out of air. And here's the finished panel. All the components are bonded together. They now proceed with the test. The panel is placed in a solar simulator. Negative and positive contacts of the solar panel are connected to a voltmeter. The panel is inserted into the simulator and a powerful lamp will illuminate it. The voltmeter is read to make sure that panels supply the electric current required. Here now is the assembly of another kind of solar panel called the amorphous silicon type. Its components were made in Europe and Asia. These here are the positive and negative connecting wires of the solar panel. The panel is placed into a plastic frame and glued in place. Then the frame is screwed tight so that it won't move. The solar panel made up of crystalline silicon modules is put onto an ABS plastic frame. It's now finished. Fabricating this panel will have required about 1 hour of work. 6 of them are made here every day. So you think you can make that last quick trip when the gas tank reads empty? This plastic container should come in real handy for the walk to your nearest gas station. Plastic gas containers are made from these granules, composed of a concentrated colorant and a UV-resistant additive. They're mixed with white granules, which is the primary material, called high-density polyethylene, and recycled plastic, which has been ground up in a granulator. It's all dumped into this milling machine. These granules are all mixed together and melted. The melted plastic will be blown in and will take shape within this mold made of very high-quality, dense aluminum called aviation type. Blow molding continues and produces a soft plastic tube. This is cut and placed in the mold. Then this nozzle pumps the plastic into the mold shell. The container is unmolded and moves along on a conveyor. There's another way to mold plastic, by rotation. This previously colored powder has a 35 mesh size, which is just a little larger than flour. Low-density linear polyethylene is poured into the bottom of the mold. The mold has a cover which will be well closed, then placed on a steel support. This support is articulated by an arm on 2 rotation axes simultaneously. This action allows the plastic powder to distribute itself thoroughly throughout the mold. The mold is placed in an oven which generates a temperature of 310 degrees centigrade. About 15 minutes is needed for the polyethylene powder to melt, and another 15 minutes to allow the piece to adequately cool before unmolding it. The mold cover is lifted off and the plastic piece is unmolded. Gloves must be worn since the piece and the mold are still very hot. Here they fabricate a mechanism cover for a stationary bicycle. It's held in place by a cutting pattern and openings are cut with a pneumatic tool. Holes are made with a drill. The casing is now completed. Now we get back to the previous blow molding process. This type of molding produces residues which have to be eliminated. These surplus pieces are cut with this small saw. The now hardened scraps are sent to the granulator to be reduced into granules, which will be newly added into the mixer to make other plastic containers. This small pneumatic drill pierces the container's vent hole. The container circulates from one step to another on the conveyor. The next steps will be accomplished by robotic arms. And then the final elements are attached, such as the pouring spout. Then a sealing stopper equipped with a rubber washer prevents leaks. And finally, the cap of the neck is automatically screwed into place. Depending on the thickness of the mold, the blowing procedure allows the production of between 30 and 120 containers an hour. The rotation process takes between 45 and 60 minutes to make a unit. Finished containers are now ready for packaging and delivery. This can be a dangerous curve if you're a hockey goalie facing a fast-approaching puck. You shoot, you score, with a stick blade shape and curve custom made just for you. The Irish, some 1,200 years ago, were playing hurling, a form of hockey on grass with simple goal zones. In the 17th century, Amerindians used curved sticks in a game they called Batagaway. The national sport we play today was developed by British soldiers in 1855 at Kingston, Ontario, as a pastime during Upper Canada's long winters. Making a hockey stick requires the assembly of several pieces of wood and fiberglass. These sticks are all replicas of those of great hockey professionals. The shaft is made of a piece of poplar onto which they glue two thin strips of birch. This is placed on a circular conveyor equipped with a press which holds the pieces together while the glue dries. Then this multi-bladed saw cuts the wood into 3 identical stick shaft pieces. The shafts are then moved to a precision sander. The shaft has to be reinforced with fiberglass. With a roller, they apply a coat of epoxy resin, a kind of glue, onto which they place carbon-reinforced fiberglass. The resin has to dry and harden. The stick shaft is placed in an individual mold and cooked in this press heated to 80 degrees for 12 minutes. The shaft then goes to a milling machine equipped with diamond-headed knives which round the edges. A finish is applied to the shaft for a second sanding, which brings out the grain of the wood. Now they glue small blocks to the end of the shaft in order to attach the blade. Urethane glue is used, which resists water and humidity, and is specially made for hockey sticks. This glue dries in 15 minutes at 38 degrees centigrade. The blade will soon be attached to the stick shaft. This slitter cuts the shaft in wood blocks in order to slide in the blade. This machine inserts the glue in the blade into the stick shaft. The stick is placed on a conveyor leading it to the next step and giving the glue a chance to dry well. Then both sides of the blade are sanded to thin them. The sticks are replicas of those used by hockey professionals. This computer-controlled digital lathe cuts the blade. Data on all the cuts are in the computer's memory. The blade now has to be curved. It's steamed for a minute, allowing humidity to penetrate the wood and make it flexible. Then the blade is placed in this curved mold, where it's heated for 50 seconds at 55 degrees centigrade. The blade is then worked by hand. The new blade is compared with the pattern of a hockey player's stick to obtain precisely the same curvature. This is why the company keeps 6,000 blades on hand. Now the blade is sanded down to the desired thickness. The blade must also be reinforced. Fiberglass cloth is soaked with epoxy resin. Then they place the cloth on the blade and leave a good margin around it. They get rid of air bubbles, then put it into an oven to dry at 32 degrees over 24 hours. The surplus fiberglass hardens and is cut with a bandsaw. This step requires quite a degree of manual dexterity. Finishing is done with this circular sander. Finally, the blade is dipped into this epoxy resin to give it a nice luster. All that remains is to paint the stick. Here the company logos are applied via silk screening. Beside the 6,000 personal models of professional hockey players, this company produces 65 other models of hockey sticks. Each week, they make about 40,000 for an annual total of 1,600,000 sticks. I hope you enjoyed our show today. We wanted to take you behind the scenes of the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.